Hello everyone, welcome to APS Deep Academy and this is your mentor Swati Joshi. In last class, we study about practical PN junction diodes and its working in forward bias. Now we will discuss PN junction diodes and its working in reverse bias. So practical PN junction diodes in reverse bias. Practical diode in reverse bias. Okay. Now what is happening in reverse bias? In reverse bias, the positive terminal of the diode is connected to negative of the battery and negative terminal of the diode is connected to positive of the battery. So this is the basic of reverse bias and the voltage is varying in nature. Now quickly we will review the PN junction. So this is the PN junction. If I bias it with negative biasing, what is happening? The holes are here, try to move towards the negative of the battery and electrons are here, try to move to the positive of the battery due to the attraction charges between negative polarities. So what is happening? The width here is increasing and the reverse bias voltage working as a blocking bias. This width is increasing because these charges try to move in this direction. These charges try to move in this direction. They do not want to flow inside in between the junction. If they are not flowing in between the junction, what is happening? They are opposing the current or increasing the blocking bias. So this is considered as blocking. Okay, no current is flowing here. Now what happened? At a certain value, when this reverse bias voltage increased too much at a certain value, this depletion region or a bond inside the depletion region, the covalent bond between the atom ruptured. Due to the bond, due to the due to the rupturing of the bonds, a very high current is flowing in this direction, and this region is considered as breakdown region. So we will consider a VI characteristic graph first so that we will understand it fully. So if this is reverse current which is in microampere and this is voltage which is in negative side. So what is happening till a particular value, the current is considered as IS or reverse saturation current or reverse current, and after that it is attaining a breakdown voltage. Then this current is increasing too much sharply and heavily. So first, we understand why this current is flowing. Although this current is very negligible, IS is very negligible, but why it is flowing? It is flowing due to the random motion or the motion of charge carrier inside the depletion region and due to the process of the thermal voltage. Okay, due to the application of thermal voltage, the charge inside the layer are try to collide with each other and try to diffuse inside each other. So due to the process of this higher concentration to lower concentration movement, the diffusion current is flowing, and this diffusion current is nothing but reverse saturation current or IS. Okay, now after that, this is our reverse current which is considered as reverse breakdown current also. So this current is very high. Now we will understand the mechanism of breakdown. So there are two kinds of breakdown, one is Zener and one is Avalanche. We will discuss it in detail so that we will understand why this current is happening and what is the application of diode in reverse biasing, why we use diodes in reverse biasing. Okay. Now we will discuss the reverse bias case here. So reverse bias working in breakdown regions. So there are two kinds of breakdowns, one is Zener and one is Avalanche. In Zener, the impurity level is very high, so they are occur in heavily doped junction. Avalanche occur in lightly doped junction, so impurity is little less. So if Zener occurring in high impurity, so the width of the depletion region is little thinner, and in Avalanche the width of the depletion region is wider than the Zener. Okay, so these two parameters we have to consider, then we will discuss it in detail. Now, so with the help of PN junction, we will understand this. This is P side, this is N side, P side positive, N side negative, P side connected to the negative of the battery, N side connected to the positive of the battery. So this is the basic configuration in reverse biasing. The voltage is varying in nature. So what is happening? Due to this thing, these positive charges are attracting towards the negative terminal of battery, negative charges attracting towards the positive terminal of the battery. It means this layer is widened. Okay, and it will stretch till a particular limit. let's say this is the limit, maximum limit where this layer can stretch. This is the maximum limit. After that, it can't stretch more. Okay, so the stretching is in maximum, the layer is in stretch maximum. So let's say this is at higher voltage. Let's say this is happening in 2 volt. Minus 2 volt, this layer is very, very high. If this is very, very high, what is happening? The electrons are, forcefully suppressed to this side, and holes are forcefully suppressed to this side. So they are, forcefully suppressed. Suppression. The suppression is forcefully. So what is happening? This is the positive charge here. This is the negative charge here, and they both are attracting each other. But what happened? If we are increasing the biasing, so this charge is little more, and this is forcing to this electron to break this layer and try to take part in conduction with the hole. So conduction only take part when this electron combine with the hole, or when the break will bond, or when the free charge carrier are generated. So free charge carrier generated when the covalent bond will rupture. So if this electron jump with full of energy and jump into this side P region and try to capturing the hole, then the bond of the system is breaking. The covalent bond which are bounding the electrons are breaking, and because the voltage level is very, very high, so that the bonds are breaking, and if the bonds are breaking, then the free electrons are releasing, and if the free electron are releasing, what is happening? The abrupt change in current we are happening at the, let's say, in minus 2 volt. The abrupt change, current is increasing heavily, current is increasing very, very heavily. So this is happening in Zener. What is happening in Zener? If we are increasing a voltage at a certain level, the thickness of the wideness of the layer is in extreme level. What is happening? The electron are suppressed, heavily suppressed in one region, holes are suppressed into another region, and electron try to jump towards the hole. So when they are jumping, the bonds are breaking and free electron are releasing. So this is the process of generation of the electricity or electric current here. This current is very, very, very high in nature. Okay, now you will understand why the breakdown current is very, very high in nature, because it is due to the breaking of the bonds here. Okay, now we will consider the second mechanism, which is our avalanche, which is nothing but similar like Zener, but happening in little higher voltage. Why so? Because the width of the depletion region is wide. So initiating energy or the voltage which is required to widen this depletion region is little much than Zener. So if Zener occur at minus 2 volt, let's say avalanche will occur at minus 5 volt. Same process happening, current will increase abruptly. Same thing is happening, and but this we call avalanche breakdown. Why so? It is happening in higher voltage than Zener because the wideness of the layer. So I think you understand the Zener and avalanche mechanism in detail. If you have any query, just mention it in comment box. I will try to solve this. So this is enough for today's class. I will see you in next class. Thank you.